example comes out of section 2.8, higher derivatives, and it also will review a bit of 2.7, implicit differentiation. Habit to get into is simplify as much as you can before you then start to try to take another derivative of this thing. If you prefer to call that y prime, that's good, but dy by dx is good as well. So now the derivative of that is that'll be my second derivative. So d 2y over dx squared, or if you prefer y prime prime, is going to equal the derivative of this expression we just found. So to do that, I'm going to use the quotient rule to say, well, it's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And however you've remembered that, or if you have it sitting on a formula sheet beside you. So my second derivative is equal to, if I simplify a little bit, negative 2xy squared plus 2x squared y dy by dx over y to the 4. Now you get part marks for getting that far. You've done more than half the work. But we know what dy by dx is. And so we should substitute for this dy by dx that expression that we found, which was negative x squared over y squared. So take that a step further. I leave this little bit for a second. 2x squared y times negative x squared over y squared over y to the 4th. And so I can simplify that slightly further just by doing regular multiplying and factoring, dealing with denominators. Leaving the first bit again still the same, negative 2xy squared. Now I'll have minus 2x to the 4 over y to the 4. Again, just by saying, oh well, I had to multiply x squared times x squared to get that x to the 4. Y over y squared gives me y to the minus 1 over y. This fraction within fraction kind of appearance is something that we wouldn't leave at the final answer. The fastest way to get rid of that is multiply the top and the bottom by y, which would give me negative 2xy cubed minus 2x to the 4 over y to the 5. Now that's quite good. You've done 80% to 90% of the work to this point, but never forget to factor in your final step whatever you have, because in some cases it really simplifies quite a bit. In this case I have a negative 2x as a common factor, leaving me with y cubed plus x cubed on the numerator over y to the 5th. And again, that's awesome if you've done all those steps. But if you recognize right from the start that y cubed plus x cubed or x cubed plus y cubed was just negative 8 from the very beginning, that's the expression they gave us, you can put negative 8 in there and you have negative 2x times negative 8 over y to the 5, which is 16x over y to the 5. And that is your simplified version of the second derivative using implicit differentiation. And so good practice of both 2.7 and the ideas now in 2.8.